Welcome to part 3 of the ionized water tea bag demo, microclustering or pH. I'm Randy Sharp. In this demonstration I will show that while alkaline water makes tea primarily because the higher pH makes the compounds in the tea more water soluble, there is also another mechanism at work. Many foods, including teas, contain compounds called anthocyanins, natural pH indicators which will change color with changes in pH in the same way that pH drops do, although the colors aren't the same. So in this demonstration, I'm going to use Dasani water. I'm going to fill both of the cups with 8 ounces. I'm going to use the cup on the left as a visual indicator of what's going on with the pH. Slightly acidic. I can check the pH. Tested it a number of times. It usually makes it down below 7 if you mess with it long enough. Anyways, you can see that's going down. And what I'm going to do, first of all, is I'm going to place a tea bag, Yamamoto green tea, into the Dasani. Show that it doesn't make tea, just like in the demo. And then what I'm going to do is, even though that looks clear, I'm going to show you that the natural pH compounds, the anthocyanins, are already in the water. And all I have to do is add about 5 drops of ammonia. And that water will automatically look like tea. As you can see, I did raise the pH up over 9.5, I'm sure. We could double check that with the meter. Reading 9.1, 9.2. So that's alkaline water for sure. But as you can see, the natural pH indicators in the tea dissolve into the neutral pH water, but they don't change color until there is actually a change in the pH. Therefore, the tea color seen during the tea bag demo is really a combination of actual tea being made as well as the response of the natural pH indicators to the change in pH. Before I end this video, I have decided to do an unadvertised special which may be the most powerful of all. I will show that just like with the distilled water, even carbonated soda loaded with sugar can make tea if its pH is raised. So I'm going to add some Sprite soda, about 8 ounces again. We can check the pH. Probably going to be below 3, 2.6. So that's about what we would expect. And then I've got a pre-measured amount of ammonia I'm going to add. It's 10 teaspoons. It takes quite a lot to get the pH up close to that 9.5 range. I can stir that and we can test it and see it's 9.6, 9.7. Close enough. I'm going to take one more fresh Yamamoto green tea bag. Show you that just like with all the other fluids that we raised to 9.5, that tea bag will make tea. Now if that doesn't persuade you, I guess nothing will. So in conclusion, after seeing this demonstration, I hope you will consider that 1. The ionized water's ability to make tea is more likely explained by a difference in pH rather than the property of microclustering. And 2. The color we see when the tea bag is dipped into the 9.5 pH water is due, at least in part, to natural pH indicators in the tea. The fact that the tea water does taste like tea indicates that there is also tea being made, but the final tea color is actually the result of both tea being made and the pH indicator. Please keep in mind that it has not been my purpose to attempt to refute the theory of microclustering, because I am not able to do that, but only to question the claim that it explains what is happening in the Teabag demo. If you have any questions or need clarification on anything in this presentation, please contact me via Facebook. If I haven't persuaded you and you are more comfortable continuing with the microclustering explanation, that is your choice. It is simply my desire for distributors to have the most accurate information at their disposal to explain what is occurring in the demo. So should you stop doing the Teabag demo? The Teabag demo shows one property of the higher pH water, the ability of the water to make acidic compounds in the tea more water soluble because of its higher pH. This demo can legitimately be used to show how you can make better tasting, less bitter coffee and tea using less coffee and fewer tea bags. But in my opinion, it is not necessary and not scientifically accurate to mention the subject of microclustering in connection with this demo. And just a note on safety, in case anyone decides to try these experiments on their own, be sure to wear safety glasses and gloves when handling the ammonia, and try not to breathe the vapors. There are other products you can use to raise the pH. For example, hot tub stores sell sodium carbonate, which is called pH increase, and you could use that if you wanted to. It wouldn't matter. For more information on pH, microclustering, and many other subjects, be sure to visit Tyler LeBaron's new website, the Molecular Hydrogen Institute, at www.molecularhydrogeninstitute.com. Also be sure to visit us in the Hydrogen Water group on Facebook.